It was about exponential and log functions. This is chapter 9. And we talked about the exponential function and we graphed one, and then we looked at logs. So this was the fact that log base A of x equals this, where this is the exponent that goes on A. To get x. Okay, so that's the exponent that goes on A to get x. And the equivalent statement that we can look at is A to the power of y is the same as x. So these are kind of the same things. And we did an example. I mean, so like log base 4 of 16. Okay. Oh, that's boring. Let's do log base 2 of 32. Log base 2 of 32. What power goes on 2 to get 32?
5.
5, okay. And then we looked at some different ones. Oh, I need to clarify from yesterday. I made a mistake in the notes. I went back and changed it after class because someone stayed and asked, but you wouldn't have known. So we did this. Let's look at this. Log base square root of 7 of 7. That was the problem I believe I gave, okay? What exponent will go on square root of 7 to get 7?
Is it 2?
It would be a 2. And I think yesterday I said a half, okay? So that was my mistake. Now, if it were the other way around, if it were, say, 5 down here and square root of 5 in here, what would be the exponent that goes on 5 now to give me square root of 5?
A half.
That would be a half, okay? So the homework today is a bunch of these, like figuring out your exponents that will go on the base. There's a whole bunch of these to practice today in the hand-in homework that's due tonight. So you do have a quiz and you do have hand-in homework tonight. But then I didn't make any homework due over the weekend. That might be a mistake. It might be a good time to do a review test or something. I'll think about it. Yeah, we'll see. Start getting you guys ready for the final. So then maybe today's homework I'll give you till Wednesday to do it so you can get it done and turn it in tonight, or Wednesday. Is that preferred, or do you just want to get it all done today? It's up to you. I guess you'll have a choice. I understand, Braxton, but the thing is that when we come back from break, what you need to understand is that we have 2 weeks basically of class. So we'll have a week of lecture and then a week of lecture and a test. And then the week after that, it's 3 weeks to the final when you get back, basically. Okay. Yeah, okay. So I might extend today's homework till tomorrow. The only thing is that there are some extra problems in there that are on your quiz today. All right, so I'll think about that and let you know. All right, so today what I want to focus on is, let's look at examples like this. A couple different properties to notice. If we have log base 5 of 5 to the 3rd power. So simplify. Okay, simplify. Okay, 5. What is the exponent? Here's the question you're asking yourself. What is the exponent that goes on 5 that will give you 5 to the 3rd?
3.
What's the answer to that?
3.
Yeah, it's just 3. Okay. What if I have log base 9 of 9 to the square root of 7?
Square root of 7.
It's just square root of 7. And then one more, log base 17 of 17 to the third. Oh, that's boring.
3.
Yeah, it would be 3. I'm going to make it -3, but it's -3, okay? So here's the property. If I have log base A of a to the power of n, notice that these are the same, right? Then what is this going to always be?
N.
It's just n. Okay, so when those are the same, it's just because it's the exponent you will put on it. It's right there in front of your face, basically, okay? Here's another fact that is helpful to know. Simplify 4 to the log base 4 of 16. Gosh, sorry guys. All right. So let's focus on the log part first. Okay, let's focus on this. Stop popping up. If I want to simplify this, log base 4 of 16, what exponent goes on 4 to get 16?
2.
2. Okay, so this is really equal 4 to the power of 2, which is what? 16. Right? Let's look at another one. 5 to the log base 5 of 3. Okay. This answer, yeah, is that what I want? That's right. This is the power that goes on 5 to get 3. The power that goes on 5 to get 3. So whatever that power is, if I raise 5 to that power, what should I get? First of all, okay, so here's the question. Log base 5 of 3, is that going to be a whole number?
No.
No, it's some decimal. But I know that if I take what this tells me, what this piece right here tells me, is if I take 5 to whatever this power is, I'm going to get 3. So if I take this 5 and raise it to that same power, what is that going to equal? 3.
3.
Yes. Okay. So what's the pattern here between these two examples?
If the number outside the log and the number like right after the log are the same, it's just the number that's in the parentheses. It's just the power that is being multiplied by or something like that.
Yes. Okay. So if, to put it in a little more mathematical terms, if your base is raised to a log of the same base, basically same base, then whatever is in the parentheses, this is just equal to that. Okay. In mathematical language, here's the fact. If I take a, any number, and I raise it to log base a of n, it's just going to be whatever is the input in your log function, that n. Okay. So that's another thing that will be helpful to know. I don't know how much, you definitely want to know that going into like pre-calc, okay? But it is this idea that it's the exponent. When these bases are the same, the exponent of this thing is the same thing you would put on 5, so you end up just getting 3. I don't know. Okay, so let's look at solving log equations. So 1, solve log base 3 of x equal to 4. Okay. So what this is saying is that 4 is the exponent that goes on 3 that will give me x. So do you guys see that? Remember, log base a of x equals y. This is the exponent that goes on a. So 4 is the exponent that goes on 3 that will give me x. So that's just going to be x is 81. And you can check and see that this works, right? Log base 3 of 81 is 4. 3 to the 4th power is 81. Okay. 2, let's do this. Log base 2 of x minus 3 equals 3. So I want to rewrite this using this definition. So 3 is the power that goes on my base 2 that's going to give me what's inside here, x minus 3. Any questions on how I'm writing that? How we're setting this up? So to solve a log equation, you have to rewrite it without the log. You cannot do operations with log present. It's because this stuff is trapped inside this log, okay? So we rewrite it using the definition. So this is 8 is equal to x minus 3, and then you add 3 to both sides, and x is equal to 8. And then it's easy to check this.
Do you mean 11?
Oh yeah, 11, thank you. Log base 2 of 11 minus 3 is log base 2 of 8, which is 3. And that's what I would want to get, okay? All right. So there's, here's one more. And then what we're going to need to do is look at log a little more carefully, explore some properties that will help us solve some of these because they're not always going to be so straightforward. So log base 4 of 2x minus 3 minus 2 is equal to 0. So first, isolate log. Okay, I got to get log by itself in order to use this definition. So we're going to add 2 to both sides. Okay, so log base 4 of 2x minus 3 is equal to 2. Then, once again, your base is the base. This is the power. 4 to the power of 2 is equal to what's inside. So you rewrite. Okay, yes, you guys are right. So this is going to be 16 equals 2x minus 3. You add 3. 19 equals 2x divided by 2. And we have x is 19 halves. Okay, so just some basic log equations. And we're going to build on that. Hopefully by the end of this lesson, I'll get to that, but we'll see. Okay, any questions? Everybody good with that? All right, let's look at graphs of logs. Okay, because they do have a basic shape that we need to be comfortable with. So here's my example. we're going to graph f of x is equal to log base 2 of x. Okay. This is a function, has input outputs. Okay. So I'm going to put a lot of points in here. Let's see. I want 0, 1, 2, 4, -1, -2. Try a couple negatives. And then we're going to try 5. Why do these lines get longer as I go down? I don't know. And then we'll try a couple fractions, 1/2 and 1/4. So we just want to practice plugging into the log function and seeing what happens. So let's start with x equal to 0. So f of 0 is log base 2 of 0. So basically what I'm asking myself is 2 to what power is going to give me 0? What do you guys think? Okay, Armarian. Okay, so what can I raise 2 to get 0? Okay, if I do 2 to the first, that's 2. And if I do 2 to the -1, that's 1/2.
And if you do 2 to the 0, that's 1.
Yeah, so that's right. This is undefined. Okay, another way to write that is DNE for does not exist. Okay. Okay, so that goes, well, all right, let's keep going. I don't want to ruin all the surprises for you guys. X is 1, so f of 1 is log base 2 of 1. Okay, so I'm basically asking 2 to what power is going to give me 1? What is x?
0.
X is 0. I'm sorry. F of 1 is 0. The output is 0. So this is 0. So that's the 0.10. So that we finally have 1 point on our graph. All right, let's look at x is 2. F of 2 is log base 2 of 2. 2 to what power gives me 2?
1.
1. So this is 1. So this is power 2, 1. All right. X is 4. So f of 4 is log base 2 of 4. So 2 to what power will give me 4?
2.
2. Any questions on how we're getting these? I stopped rewriting it as a, I only want to have to rewrite it, you know, like this when I have to think. If you can figure it out in your head, go for it, okay? All right, let's look at x is -1. So f of -1 means log base 2 of -1. Sorry, guys. Log base 2 of -1. So 2 to what power is going to give me -1? Marianne's quick. 2 to what power will give me a -1? Here's the thing. Go ahead. What's that?
I would say undefined.
It is undefined because whatever I put in that exponent is either going to make it bigger, like 2 to the 3rd, 2 to the 4th, 2 to the 5th. Or if I make it negative, it just makes it smaller because it flips it. 1/2, 1/4, 1/6. You know what I'm saying? So this is also undefined. So this does not exist. And Amarian's right. This is a domain restriction. So when we defined log, the log function yesterday, what I told you was that the domain of logs, so the inputs have to be positive. So x has to be greater than 0. So then what does it mean about this -2 here? If I try to put -2 in,
Does not exist.
yeah, it's going to be the same issue. Okay. All right, now let's look at x equal to 5. So I want f of 5 is log base 2 of 5. So what can I put, what power goes on 2 that will give me 5? Oh,
Wouldn't it be like some sort of decimal?
yeah, it's going to be an approximation. So it's going to be about 2.2 maybe, 2.1. So this is an approximation, 2.1. Or I put 2.2, we'll stick with that, 2.2. So 5 comma 2.2. We can only approximate that one, okay? All right, what about, now what if I do this? F of 1/2 is log base 2 of 1/2. So basically, what power do I put on 2 to get 1/2?
-1.
Yes. All right. Any questions on that? F of 1/4 is what power do I put on 2 to get 1/4?
-2.
-2. So this is 1/4 comma -2. All right, any questions on how I got any of those inputs, outputs? Log is a little bit more challenging to calculate, but it's okay. We're good. Okay, now let's graph it. Okay. So here's my x's, here's my y's. All right, so 1, 2, how far up did I go? Not far, 3, 4. Oh, so you know what? I'm gonna make these a little bit more spaced out. All right. So 1, 0. 1, 0 is right here. Then I have 2, 1. So 2, 1. And then we have 4, 2. 1, 2, 3, 4, 2. Is this looking like a line? No. All right, let's look at 5. Oh, I did put 5 in here. 5 is going to be 2.2. So like right here. Just a little bit above 2. So this is 5 and approximately 2.2. Here's 4 comma 2, 1 comma 2. I'm sorry, 2 comma 1. Okay. Now let's go, we can't put any negatives in, but we can put in fractions. So let's look at a half. Here's a half, and that was -1. Here's 1/4. That was -2. And what happened when I tried to put 0 in my function? It was undefined, right? So this right here means that here's 0, okay? I will never reach that point. What's that called when you can't get there? A what?
Asymptote.
An asymptote, yep. So this curve is going to come really, really close to the y-axis. It's going to ride along it, and then it will slowly increase, okay? It will slowly increase. So this is the log function. This is x equals 0 is a vertical asymptote. Okay, and notice that there's no negative inputs. That's what we said. The domain does not include any negative numbers or 0. Any questions about that? So this is the graph of f of x equals log base 2 of x.
Miss G.
Yes.
So technically, with a log graph, there will it might be certain cases, but as for now, as I'm learning it, or it will always be to the right side. Like there will never be any negative x values. Like,
Well, when it's the basic log graph, yes. But
okay.
when you get up into pre-calc, you're going to have to graph logs that look like this. We're not going to do it in this course, but negative log, you could have like -3 times log base 4 of 2x minus 1. And then that is going to be shifted. It's going to be somewhere else on your graph. And it may be in the negative space. But the point is that once you plug it in, it's going to look like this curve. The curve can change. Okay, there's things that we can do that could reflect it this way. Okay, it can be reflected up. Okay, so it can move on the grid, but the basic graph, this is the basic log graph of like f of x is log base a of x, looks like this. Okay.
Okay, thank you.
With an asymptote x equals 0. So so just so you know, the basic graph, let me write this in here so if you're ever looking back, you're like, what was she talking about? The basic graph can shift and reflect. Can be shifted and reflected too, depending on the formula. Can be shifted and reflected depending on the formula. I'm going to call it formula of the function, even though that's kind of not the right language, but you guys get what I'm saying, right? If you're not, tell me.
We are.
All right. Okay, so that's the graph, and we get a little experience plugging in. Now, what we're going to talk about is domain of log functions in more detail. And this is going to bring some stuff together for us. Okay. So let's just start with looking at the domain of this function. What is the domain of log base 2 of x? Let's just name this first of all. If you're looking at this graph, what would you say your domain is? Where does the input start? This is good review because I've written this down, but looking at the graph, where does my function have inputs and outputs all defined? Oh, Cornelius, yes. Greater than 0, okay, but not including 0. So for this basic graph, it was 0 to infinity. Okay, any questions? All right, now we're going to look at some different, find the domain of g of x is equal to log base 4 of 3 minus x. So now this is not a basic log function. My input is a little bit different. It shifts my graph, just so you know. This is going to shift my graph on the axes. But we don't have to think about that too hard because it's simple, okay? To solve for the domain, find where the inputs will be greater than 0. Okay, so I just take the inside of my function and I solve this. I just take the inputs and I find when that portion is always going to be positive. So how would I solve this? What would you get, McKenna?
X is less than 3.
Yes, very good. I would add X to both sides and it looks like this, but then she said it really nicely. I'm going to put the X on the left and it's actually less than 3. And then when we write this in interval notation, okay, just realize that's not including 3, but everything less. This is negative infinity to 3, not including 3. Questions? All right, here's example 2. Find the domain of h of x is equal to log base 10 of x squared minus 3x plus 2. Okay, same method. I'm just going to take everything that's part of my input and I'm going to solve when this is greater than 0. Now, if you've been paying attention, these are 2 different types of inequalities. Which one is linear and which one is nonlinear?
The first one is linear and the second one is quadratic.
It's quadratic, that's right. So this was a linear inequality. Let me put that in red. Because of that, we could just solve it like we normally would. But when I do this, finding this domain, I end up with a nonlinear inequality, which means that we need a what? Sign chart. Okay. So here's an example of where the sign chart, using that sign chart, that method that we talked about comes in handy. Okay. So step 1, I have it 0 on one side, so we don't have to worry about that. I want to find my zeros and my undefines. Okay. So my function looks like this. X squared minus 3x plus 2. My zeros are going to be when this function is equal to 0. Remember, it's the x-intercepts. How do we factor this? Let me call on somebody. How about Lauren? How would you factor this?
X minus 1 and x minus 2.
Oh, okay. Lauren threw her voice to Cornelius. That's okay.
Oh, I'm sorry.
That's okay. It's just, I feel like I'm being a neglectful teacher. I should be pulling you guys into my lesson. Cornelius needs no pulling, and that's good. I appreciate that, Cornelius. All right, so x is 1 and x is 2. So that means these points are my zeros, okay? What about undefines? When will this function be undefined? None. Okay. There are no undefines for the quadratic. Now understand, I'm taking the function out of the log to solve just this piece, but the answer to this will give me my domain of the log. Okay. All right. So now I do my sign chart. So here we put on here 1 and 2. These are my zeros. I cannot include zeros because it's log. Okay, zeros are not included. And then I have 1, 2, 3 regions to check. And again, I'm using this function. So let me pick a number less than 1, 0. When I plug in 0, I get 0 squared minus 3 times 0 plus 2 which is positive 2, so this is positive. All right. In the second region, I have to pick a fraction. That's not fun. 1.5. But okay, so this is 3 halves. So this is 3 halves squared minus 3 times 3 halves plus 2. So that's 9/4 minus 9 halves plus 2. I have to get a common denominator. Oh, you know what we could do? Let's do this, you guys. See how much work that was? Oh, I shouldn't have erased that. Okay. Do you guys see how much work this is? Look what we can do instead. Let's use the factored form. X minus 1 and x minus 2. If I put in 1.5 minus 1 times 1.5 minus 2, then I know 1.5 minus 1, this is just a half or a positive number. 1.5 is bigger, okay? 1.5 is smaller than negative 2, and I know because the numbers are not that hard, that's going to be negative 1/2, which is going to give me negative 1/4. That is way easier to calculate than just like plugging it in. So using the factored form can be really helpful. So this is negative. Any questions on what I just did there? Let's keep using that. I like it. I'm going to use the factored form and pick 3. 3 minus 1 times 3 minus 2. That's 2 times 1. That's positive. Okay, so positive. Any questions on that? All right, now we got to go back and answer the question. And the question was, when is this going to be positive? And I see it's going to be in the first and the third region. So my answer, the domain of log, is going to happen from negative infinity to 1, not including, and then from 2 to infinity. Okay, questions on that? Everybody's good? Okay, where am I at on time? Good. We're making good time. Okay, so let's do this because this gives us another shot at practicing solving nonlinear inequalities. Okay, so find the domain of f of x equals log base 5 of the fraction x squared minus 4x plus 3 over x plus 7. Okay, so what's my restriction on log? The inside of the log function has to be what?
It has to be greater than 0.
Yes. So I'm going to take the inside and make it greater than 0. This is what I need to solve to get the domain. All right. Linear or nonlinear?
Non-linear.
Nonlinear, very nonlinear. Not only do I have a power, I have a denominator. Okay, so you guys have had some practice with this, and this is what you're going to have to do on your quiz tonight anyhow. So go ahead and see if you can figure out that sign chart. Zeros, domain, or zeros, undefines, check regions, answer the question. Go ahead and give it a try. Okay, so when you get your zeros, you set it equal to 0, and you should have gotten 1 and 3. And then your undefined is in the denominator, that cannot equal -7. So then on your sign chart, all these numbers need to go on here. So we have 1, 2, 3, 4 regions to check. Holy cow. There's 4 different regions. And what I would suggest is that you use the factored form to calculate. Okay, so how about Jack? I don't ever call him Jack. Jack, what number did you pick for region 1 to check? Or what number would you pick?
-8.
Very good, very good. So negative 8 minus 1. -8 minus over this. And we get -9 times -11 over -1, which is going to be +99 over -1, which is basically negative. I really don't care about the number. I just want to know the sign. All right, let's see. How about Emma? What did you pick for region 2? I'm sorry, if you said it, I didn't hear you, hon. Or if you're having audio issues, you could just put it in the chat. Or you can say pass.
Oh, now you can hear me. Okay, I picked -6.
-6. Okay, yep, we can pick -6. All right, so -6 minus 1 times -6 minus 3 over -6 plus 7. That's going to give me -7 times -9 all over +1. So this is going to come out positive. All right, and I'm at the end of class. Let me rush through the rest of this. So 2, I'm going to pick 2 minus 1 times 2 minus 3 all over 2 plus 7, which is 1 times -1 over 9. This is negative. And then if we pick 4 minus 1 times 4 minus 3 over 4 plus 7, all those are going to come out positive. So let's go back to the question. I want to know where this is positive. So it's going to be from -7 to 1, union 3 to infinity. Okay, it's going to be these 2 regions here. That's my domain. So these are the numbers that if I plug it in this log function, we can get an output. Any questions? Okay, make sure you do your quiz later, and I have a great break, and I'll see you guys Monday. Okay, Monday. Bye.
Have a great break.
Thank you.
Bye.
Bye. All right, there's still people here. So do you guys have questions? I know Thomas wants to talk to me, but Che, Jahan, Braxton. Oh, bye, Jahan. Thank you. Pardon me. Che, Braxton, Michael, do you guys
Yeah.
have questions?
I do have another question besides what I was gonna ask.
Okay.
How long is the
So hold
quiz
on a
gonna-
second. If these guys, I'm gonna put them in the waiting room. If they're not here to, that way we can have privacy. Michael. All right. Okay, now it's just you and me. Go ahead.
How long is the quiz going to be up today?
3 to 4 questions. So there will be a
No, I
graphing
meant-
and then
Is it gonna be up for a few hours or?
it's you were late. What happened? Did you oversleep?
No, I woke up and what happened was my brother came in. He told me we didn't have Wi-Fi, and so I had to call my mom, and she's in Canada at the moment.
Hmm.
So she had to pay the bill because it's under her name. I just had a bad morning.
Oh, okay.
Also tried to make breakfast, and I ended up getting burned on my arm.
Oh, I'm sorry. It'll be available at 4:30 and you got to turn in by midnight.
That's fine.
Okay. All right. Bye-bye.
Bye. Thank you.